All right, moving on with chapter 7 here. This is our chapter on conic sections. We're going to start with parabolas, which I believe are the most difficult of the four conic sections we are going to be dealing with. The other three are circles, ellipses, and hyperbolas. And I believe parabolas are the most difficult. So we'll get the most difficult one out of the way, and then hopefully the rest of the rest of the chapter will be a little bit easier. Um, your standard forms, different books have them different ways, but this is the standard form we are going to deal with this year. Uh, and you can read them. You have x minus h squared equals some stuff, or y minus k squared equals this stuff. If your x is squared, your parabola will either open up or down depending on whether p is positive or negative. If the y is squared, then your parabola will open left or right depending on whether p is positive or negative. So those are your standard forms of your parabola. A little bit of vocab with your parabola. I'm not going to read these to you, but you can read these. Pause the video for a second and read them if you want. Um, I'm going to draw a parabola on the next page and actually point out what these different parts are. But this is the mathy definition. Actually, some of these definitions are mine. But these are the wordy definitions of your parts of the parabola. And the parabola defined is the set of all points that are the same distance, I wrote equidistant, but the same distance from the focus and the directrix. And I'll show you what that means on the next page as well. So there's those. Okay, a parabola map. I'm going to label these parts for you. Regardless of the standard form, if it opens up, down, left, or right, these things are always going to be true. Your vertex is always the ordered pair HK, and your vertex, as I said on the last page, is the tip of the parabola. So there's your vertex, and that's the ordered pair HK. The focus and the directrix. They both are p units away from the vertex. The focus, regardless of your conic section, the focus is always a point inside the parabola. This parabola just happens to be opening up, so my my focus for this parabola, I'm going to write it off to the side. Whoa, that's not an F. Okay, so this focus would be, if I go up, I said that the focus is p units from the vertex. So if I go up p units, moving up changes the y coordinate. So my focus, the ordered pair, for this one, my x coordinate didn't change. I didn't move left or right. I went straight up. So the x coordinate remains h. I started at k, and then I went up p units. So my vertex is going to be k plus whatever p is. The directrix is a line that runs underneath, in this case, the parabola, and it also is p units from the vertex. So I'm going to go p units below the vertex, and this is going to be my directrix. In this case, it's a horizontal line that runs underneath my parabola. This is my directrix. And it also is p units away from the vertex. So I go up p to get to my focus. I went down p units, whatever that number is, to get to my directrix. Now my directrix in this case is a horizontal line, and the equation of a horizontal line is y equals some number. And since I started at my vertex, which is a y coordinate of k, I went down p. So my vertex, or my directrix in this case, is going to be the line y equals k minus p. Now, if your parabola opens up, if your parabola opens down or left or right, then the way you get it, whether you add p or subtract p or something like that, can change. So we have our focus, the directrix, and our vertex. Then you have the axis of symmetry. Your axis of symmetry is the line that splits your parabola into two equal pieces. That's going to be a line that comes right down the middle like this, and that's going to be our axis of symmetry. That's probably the easiest one to remember. So this is the axis of symmetry. And this axis of symmetry is a vertical line, so it's going to be in the form x equals a number. And the x coordinate of my vertex is h, so it's going to be x equals h. And then your latus rectum, which is always fun to say. You just love to say rectum. So rectum, 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 rectum. So your latus rectum is the line. Wait, that's not what I want. I want to come back over here. Here we go. The latus rectum is the width of your parabola going through the focus. The latus rectum tells you how wide the opening is. And your latus rectum, the length of it is always 2p. The length is 2p, which means from the vertex you go left p and you go right p. And that little dotted line right there is your latus rectum. And the length of it is 2p because you went p left and p right, so we have 2p. Have to p. Have to p. Rectum. Okay, so there is your general map for your parabola. You have your axis of symmetry splitting it in half, your directrix, and your focus, which are each equidistant from the vertex. I'm going to make my focus bold again. And then you have your latus rectum, vertex, and I'm just repeating myself over and over again. So there is your general map, and we're going to use that map to sketch our graphs of the parabolas. So let's give one a shot, and I'll probably bounce back to this page while we're working so we can kind of look and see what to do. Okay, first problem, I want to graph this parabola and then find these 5, I just called it characteristics for lack of a better word. Now this one, I see that the x is squared, and I'm going to start by finding my p. This number right here is 4p. And 4p is equal to 12, and I'm going to use my advanced math to say that p is equal to 3. Okay, since p is a positive number and my x is being squared, that means this is a parabola that's going to open up. So this parabola opens up. Make a little note to myself. Okay, first thing I'm going to do is find the vertex because that's the easiest thing to find. And my vertex, it's x minus 3 and y minus 7. I'm subtracting 3 from my x. So the x coordinate of my vertex is 3, and the y coordinate of my vertex inside with the y is a 7. So my parabola is going to start at 3, 7, and from there, it's going to open up. So let's see what we're going to do to get this graph going. There, I've got my graph paper here. I'm going to 3, 7, and then I'm going to move up. So I need to leave a lot of space above my x-axis. So I need to leave room to go to the right. So I'm going to put my y-axis on the left, and then I'm going to put my x-axis really low because I know I'm not going to go down very far at all. So I'm going to go to 3, 1, 2, 3, 4, 5, 6, 7. There's my vertex. There's my starting point. Okay, from there, I know my parabola opens up. Now, this is just going to be a sketch. I'm going to erase this and make a more accurate parabola later, but I know my parabola opens up. Since my parabola opens up, I know my focus is going to be inside the parabola. My focus is going to be up here somewhere. I'm looking in this area for my focus. And remember, the focus is p units away from the vertex. So I'm going to go back to my graph, and I'm going to think, well, if p is 3, then to get to my focus, I'm going to count up 3 units. There's my focus right there. So there's my focus, and I can simply count that. I was at the ordered pair 3, 7. Now I went up to 8, 9, 10. So my focus is at the ordered pair 3, 10. And then I'm going to do my directrix. The directrix is the same distance from the vertex, only I need to go down. So my directrix is going to be 3 units below my vertex, and it is a horizontal line. It's going to look like this. I meant for that to be dotted. So that's what my directrix is going to look like. There we go. Now my directrix is the line. That's a horizontal line, so it's y equals. And that goes through a y coordinate of 4. So my directrix is the line, y equals 4. The axis of symmetry, I've kind of ignored that. I don't know why, but my axis of symmetry is the line that splits my parabola in half. It goes right through the vertex. So there's my axis of symmetry. It is a vertical line, and my vertical line hits the point x equals 3. So my axis of symmetry is the line x equals 3. And then the last thing I need to find is the latus rectum. And this is where I'm going to get rid of my original graph. And my latus rectum, remember that tells you the width at the focus. And if my p is 3, then I need to move 3 units to the right and 3 units to the left of my focus. And now I've got 3 points, and this is pretty good. This is going to give me a good idea of how wide my graph is. I can come down, and this parabola is going to hit, wow, that was bad. Let's erase that. My parabola is going to come down, hit that point, hit the vertex, and then it's going to go back up. And that's what this parabola is going to look like. And so that's what we do. Find your P, and that P pretty much tells you where everything's going to be in the graph. The focus is P units up. The directrix in this case was P units down. And then my lattice rectum was P units on each side of the focus. So there's that problem. Oh, I never did write my lattice rectum. The lattice rectum is the entire length across at the focus, and that entire length is, I'll do it in blue, this entire length is 6 units across the parabola at the focus. So our lattice rectum, we'll say, is 6. Good, good? Good, good. Let's try another one. Let's try this one. This time y is being squared. And if y is being squared, that means we're going to open either left or right. And this one's going to be, I don't know if it's going to be tricky or not, but there's no number in front of the x. So I'm going to put a 1 just because I like to see a number. And remember, that number is what 4p is equal to. So 4p equals 1. That means p is going to be 1/4. So 4p is 1, p is 1/4. That is a positive number. So y is being squared. That means we're either going to open left or we're going to open right. Since my p is positive, that means this parabola is going to open right. So I'm opening right. I start by finding the vertex. Now the vertex, remember you change the signs of the numbers inside the parentheses. With the x, it's x minus 3, so my x coordinate of the vertex is 3. And then with the y is a positive 1, so my y coordinate is actually going to be negative 1. You change the sign. And from the point 3, negative 1, I'm going to move to the right. So let me pull in my graph paper real quick. So there's my graph paper. And what I'm going to do, I see my P is 1/4. And remember, P is how far you move to get to your different pieces. That's a very small number. So what I'm going to do to make this graphing a little bit easier is I'm going to let each block represent 1/2. Instead of each block representing a whole unit, I'm going to let each block only represent 1/2 a unit. And that way it'll be a little bit easier to count by 1/4. So let me do that real quick. There we go. So I changed my scale to make this a little bit easier. And I'm going to start by plotting my vertex, 3, negative 1, which is right here. Remember, I'm counting by 2's. And then this parabola opens to the right. So I'm going to sketch a very rough graph of a parabola that opens to the right. Something like that. I'm going to erase that in a minute, but I'm going to stick with that just so I can kind of help myself out some. All right, now my P is 1/4. That means I need to move to the right. My focus is going to be inside the parabola. Your focus is always inside the parabola somewhere. And I'm going to need to move to the right to get to my focus. So I'm going to move right 1/4. Now remember, each block represents a half. So 1/4 is going to be right here. My focus is really close to my vertex. So if I move to the right, let's see, if I move right, I moved right, I moved right. If I move to the right, my x coordinate changes. My y coordinate stays the same. So the focus is going to be at a y coordinate of negative 1, but my x coordinate, I was at 3, and I moved to the right 1/4. So I'm going to add 1/4 to my x coordinate, and that's going to be my focus. My directrix is a line that's on the exact opposite side of my parabola, of my vertex. So my focus is 1/4 away on the other side. My focus is going to come down right, my directrix is going to come down right here. That is a vertical line, right? My directrix is a vertical line, so it's x equals, and I started at 3, then went to the left 1/4. So it's going to be x equals, I started at 3, moved to the left, minus 1/4. Good, 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 good. My axis of symmetry is going to be, in this case, a horizontal line that goes right through the vertex. So there's my axis of symmetry. It is a horizontal line. My horizontal line is y equals, and that is a horizontal line at negative 1. So y equals negative 1. And then my latus rectum, and this is the point where I get rid of my rough sketch. I just like to see that parabola while I'm doing the rest. So I'm going to get rid of that rough sketch. And then my latus rectum, from the vertex, I'm sorry, from the focus, I need to move 1/4 up, which is going to be half a block, and 1/4 down, like that. And with that, I have some points where I can kind of sketch the graph. So I'm going to now draw, and this one's going to be a lot skinnier. It's going to be a parabola that opens up really narrow because my latus rectum is small. Now, if I go up 1/4 and I go down 1/4, that's two distances of 1/4. And I told you earlier that your latus rectum was always 2p, and 2 times 1/4 ends up being 2/4 or 1/2. So that's going to be, whoa, that's a funny two. That's going to be the length of my latus rectum on this one. So those are two examples of how to graph. I'm not going to do any more graphing, but unfortunately, 16 minutes into the video, there's one more thing I need to show you with these. So there's your basics on graphing a parabola, but sometimes your parabola is not in standard form to begin with, and so we would have to manipulate the equation in order to get it to that standard form. So look at this. What I'm going to have to do to get this in standard form is complete the square. And to complete the square, what I do first is identify what variable is being squared. And in this first example, it's an x. So what I want to do, I'm going to move everything with an x to the other side of the equation. So I'm going to move my x squared over. And that would give me x squared plus 4x. And anything without an x needs to be on the other side of the equation, which in this case is only the 4y. So those cancel, and that's what I have. Now what we're going to do is called completing the square. I'm going to rewrite this, x squared plus 4x, and I'm going to leave a little bit of space because what I need to do now is I need to add a number. It's called completing the square, and that number comes, what we're going to do, we're going to divide this 4. Man, my sentence structure is terrible today. I have 4, and I'm going to divide that by 2. 4 divided by 2 is 2, and then I square that number. 2 squared is 4, so I put a 4 right there. Half of 4 is positive 2, so I take half of the middle number, that's positive 2, I square it, and then that's what I add right here. Now if I add to the left side of the equation, you have to add to the right side. Whatever you do to one side, you have to add to the other. So now what I've got is I've got an equation, x squared plus 4x plus 4 is equal to 4y plus 4. And then I factor both sides of the equation. The left side, the reason it's called completing the square is because it factors to a perfect square. That's x plus 2, x plus 2, or you could write that as x plus 2 squared. And then on the right side, I can factor the 4 out. 4y plus 1, and there we are in standard form. We could find our p, we can find our vertex, we can do everything with that to get our graph. Let's look at this one. Same type deal. I need to identify what the variable is that's being squared. In this case, it's the y's. So I have y squared plus positive 12y. I'm going to leave the y's on the left side of the equation. Whatever is being squared, I want that on the left side. So I'm going to move my 2x over. The variable that's not being squared, along with anything else, goes to the other side of the equation. So I've got y squared plus 12y. I'm going to go ahead and leave some space to complete the square. Equals negative 2x minus 38. So now I've got to complete the square. Half of 12 is 6. And I like to write that positive because half of 12, positive 12 is positive 6. When you square that, you get positive 36. Since I added 36 to the left side, I have to add 36 to the right side. And now I've got y squared plus 12y plus 36 equals negative 2x, and negative 38 plus 36 is negative 2, and we factor both sides of the equation. The reason I like to write this step right here, the reason I like to write that is because the number that you squared tells you how it's going to factor. Y squared plus 12y plus 36 is going to factor to y, and then positive 6 plus 6, that's the number that I squared. So y plus 6 squared. On the right side, I'm going to factor out the negative 2, and that will leave me with a positive x plus 1. And so there is our standard form for number 2. This is going to be a parabola that opens, this one's going to open left because y is squared, and I have a negative p, so that one's actually going to open left. This one's a parabola on number 1 that opens up. It's a positive p with an x squared. So there you go. 20 minutes is actually shorter than I thought it would be, so yay. You have a nice long weekend to watch this. Yay.